All right, so what is an inverse function? An inverse function nullifies or basically cancels out what was applied to the input values of another function. So let's look at an example. So right here we've got this function f of x equals x plus 4. So all these input values are increasing by 4 to produce the output value. So you can basically see that right here. Okay. So the inverse function is going to nullify and cancel out. Basically, we're just going to go backwards. So here's a little picture of this. So you go from x to y and then back to where you started. And we use this notation right here to represent the inverse function. So don't be confused. Doesn't represent a -1 exponent, okay? So these two things are not equivalent. It's just a notation, so we don't get confused. One's a function, one's the inverse. And so here we go. So our inverse function right here is going to be x minus 4. And so basically what's going on is you're taking the output values from the original function right here, and they become the input values for the inverse function. And then you can see that you go back to the original values where we started with our original function right here. Okay, and you can basically see it within the equation because you see the function was x plus 4, the inverse is minus 4, so you can see that those are just opposite operations right there. Okay, moving on down here, how can we verify whether two functions are inverses of each other? Well, since the inverse of a function takes you back to where you started, the following holds. If f and g are inverses of each other, then f of g of x will simplify down to x, and the same goes for g of f of x will simplify down to x also. Okay, so back to our example up here, because I'm actually going to do that one for part A on example 1. So it's all nice when you plug in numbers and you can see it, oh yeah, 1 plus 4 is 5 and so on, and then when you plug in 5 minus 4 goes back to 1, you can see it right in front of you, okay? But basically down here we're kind of shoring that up. We're actually kind of proving that they're inverses of each other. So instead of just plugging in a couple values, when you actually substitute in x, that's going to go ahead and make it to where it works for the set of all real numbers. So coming back down here, so basically when we do f of g of x, okay, and we already pretty much know how to do this from our composite functions, you're basically taking the x minus 4 and substituting it into the f function. Okay, so basically right here you're going to have x minus 4, and then you still have that plus 4 from the original function. So I put what we substituted in red. Okay, and then pretty simple, that cancels out and we result in x. So we showed from up here that if f and g are inverses, then this holds. Okay, so we did show that the first pair are inverses of each other. We'll go ahead and do the other, evaluate f of g of x just to make sure. Okay, so this time we're going to take the f function, substitute it into the g function. So we're going to take x plus 4 and sub it into g of x. So then we still have that minus 4 right there. And then once again, it simplifies down to x. Okay. Now, not all of these are going to work out nicely. Okay. So if they are inverses, it's going to simplify. It's going to be real nice. Okay. If not, you'll see it's going to turn into a mess. But let's go ahead and try another one here. Let's see, b right here. So we're going to do f of g of x. So once again, we're going to take this whole thing and put it right here. So we're going to get 3, and then I'll do this in a different color. Let's see, x minus 8 all over 3. And then we've got our plus 8 right here. So I substitute that in. You can see that the 3's are going to cancel. Okay, so then we're left with x minus 8, and then you still have the plus 8, which then those cancel out. Simplifies to x just like we saw on example A. Okay, let's try the other way now. So we're going to evaluate g of f of x. Okay. All right, so this time we're going to put, let's see, 3x plus 8. We're substituting that in. We got a minus 8 from the g function, and then divided by 3, all divided by 3. Okay, so then once again, this is fairly simple math right here. We're going to have those cancel out. Get 3x over 3's cancel out, simplified to x. Okay, so therefore they're going to be inverses of each other. Alrighty then, let's go ahead and look at C. So right here, let's go ahead and get started. So we'll do f of g of x. So we're going to take this whole thing right here and put it right there, just kind of like, pretty much like the last problem. So let's see, we'll color code this. So 5 and then times x plus 5 all divided by 9. We got minus 9 over here. Okay, and so then as we work this out, really you can't simplify like we did up here. You were able to cancel out the 3's. So just let's play around with it, see if anything happens. So we'll distribute the 5 and get 5x plus 25 all divided by 9 and then minus 9. Okay, we could get a common denominator if we want, just to kind of see if this will work out. So we'll go ahead and manipulate this a little bit. So we'll get 5x plus 25 all over 9 minus 81 over 9. And when we bring this together, let's see, we're going to get 5x, let's see, 25 and a minus 81. Let's see what that gives us. Minus 50, what is that, 6 all over 9. And I mean, you could keep playing around with it, but basically the end result is that it is not going to equal x. Okay, so it's not going to equal x. Okay, and so basically the result is that f and g are not going to be inverse functions. All right, let's group that, shrink that down a little bit so I can write that here. So f and g are not inverses of each other. All right, let's try one more, and that'll conclude this first example. Okay, so let's see. All right, so we're going to do f of g of x. So we're going to take this whole thing and put it right there. So once again, I'll kind of color code it to try to avoid any confusion. So 3 over x plus 4. And then we have a, yeah, that's good, that's good. And then we need a minus 4 from the f function right there. So we'll go ahead and do that. Okay, so we kind of look, how can we simplify this? Well, right here, this should stick out. So we can do that. So we end up with 3 over x. And then we have the quotient of potentially 2 fractions, because this could, be 3 over 1 or whatever. So we're going to have to go ahead and do keep, change, flip. And so what we're going to do is keep the top the same, change it to multiplication, and flip the denominator. And then once again, we can see that this works out real nice. The 3's are going to basically cancel each other out. And there we go. So there's the first one. All right, now let's approach it from the other way. So now we're going to do g of f of x. Okay, so this time we're substituting this in down here. So let's see, we're going to do 3 over, and then we're going to have 3 over x minus 4. Let's see, go back to my blue. Let's see, then we get a plus 4 over here. Okay, so we're going to have to do the same thing I did up above with this first fraction right here. So this is going to become 3 times x minus 4 all over 3. And then you have your plus 4 right here. Right? And so then 3's will cancel. And so we end up with x minus 4 plus 4. And we can see that it simplifies to x. So yes, f and g are inverses of each other in this case. Okay, so that concludes the first example.